Okay, so first of all we will talk about two protocol. One is ICMP and second one is ARP protocol. You all know the use of ARP protocol. It is used to resolve
MAC
which type?
address.
MAC address. From what ARP protocol need to find MAC address?
Table.
IP address. From IP
IP
address
address.
it can find MAC address, na?
Yeah, yeah.
Right? And ping is a utility which use ICMP protocol. ICMP protocol is a protocol which is used to check connectivity between two devices. Connectivity between two devices. Guys, there are several type of ICMP messages, but today we will talk about two types of ICMP messages. One is ICMP request and another one is ICMP reply. There are two type of ICM. Yes, if anyone want to speak.
सर थोड़ा वॉल्यूम रेज कर सकते हैं?
वॉल्यूम वॉल्यूम राइज कैसे करेंगे? वॉल्यूम. Okay, so we will discuss two types of ICMP message. First one is ICMP request message, ICMP request, and second one is ICMP reply message. After that, when we will talk about ARP, so again we will talk two types of ARP message. One is ARP request. First one is ARP request, ARP request, and second one is ARP reply. Now, can anyone tell me how we identify ICMP request message or reply message? With type code, guys. With type code. You know, ICMP request type code is type code of ICMP request message is 8. And if I will talk about reply message, so type code of reply message is, yes guys, tell me, 0. Okay, and ARP request and ARP reply. ARP request, how we identify ARP request? With opcode, operation code, with opcode, operation code, opcode, operation code. If opcode value is 1, that means it is an
Ankush, can
ARP
you please mute
request.
your...
If opcode value is 1, that means it is an ARP request, and if opcode value is 2, that means it is an ARP reply. Done. Now see, let's say I have two computer A and computer B. Okay, on both machine we need to configure IP address, right, to make communication possible. Here to here, PC1 can ping to PC2 if you have configured the IP address on both devices. This is, let's say, PC1 and this is PC2. MAC address of this device is, let's say, 0A. MAC address, as you know, MAC address is hard coded on NIC, port. So let's say MAC address of PC1 is 0A and MAC address of PC2 is 0B. Okay, here let's say I have defined one IP address 10.1.1.1 10.1.1.1/24, and here I have assigned one IP address on PC number 2, that is, let's say 10.1.1.2/24. Okay, on both machine we have defined IP address from same subnet, if anyone knows subnetting. Okay, Now, if PC1 want to ping PC2, PC1 just want to know the connectivity with PC2, that there is connectivity or not. So PC1 is going to ping which IP address? IP address of PC2. Yes or no? Ping and 10.1.1.2. Now what will happen? First of all, what will happen, guys, on PC number 1 when I will type this command in CMD? And before it, when you will configure the IP address on this machine, what will happen? First of all, this machine will check duplicacy. That is, IP address is duplicate or not. Is it IP address unique in the network or not? Yes or no? With the help of which message? Yesterday we discussed this. Yesterday we discussed this. That's why I'm asking you guys. With the help of which
ARP request?
ARP request? No.
GR.
Yes, with the help of GARP, Gracious ARP.
ARP.
And in Gracious ARP, what will be the source IP address? Let's say when PC1 will generate Gracious ARP, what will be the source IP address? 10.1.1.1, and destination IP address same, 10.1.1.1. Target IP address and sender IP address both will be the IP address of sender machine, the machine who is generating the ARP, Gracious ARP. Gracious ARP is used to check duplicate IP address. Both machine will generate Gracious ARP and both machine will not receive any reply message of Gracious ARP. So both machine will assign this IP address to their interface, to their NIC. Okay.
Profile G, here
Yeah.
I have one doubt.
Yeah.
That Gracious ARP, when that reply will come, like that duplication IP, yeah, it will generate any code or a type of code here.
Gracious ARP is layer 2 protocol,
Okay.
right? So whenever ARPA protocol will encapsulate layer 2 protocol, there is one type field, right? So definitely Gracious ARP will have one type code value.
Yeah, actually, what is that code? Actually, I have to come to know that code.
Okay, I will show you in the capturing. When I will capture the Gracious ARP packet, I will show you what is the code. I also, don't, you know, it's,
Yeah, it's very difficult to remember.
Yeah,
Yeah.
exactly.
Okay.
So I
Yeah,
don't
maybe
know the
you
code.
can explain Gracious ARP once more, sir, if possible, if time constraints
Gracious
not there.
ARP is used to check duplicate IP address. You know, when you will assign this IP address on interface of PC1, PC1 will first generate one message, that is Gracious ARP, GR. In the Gracious ARP, it will put source IP address and destination IP address. Both will be the IP address of PC1, like 10.1.1.1 source, and destination will be also same, 10.1.1.1. This is the layer 3 information. At layer 2, it will be broadcast. At layer 2, destination will be broadcast. So who will generate reply to this message? Which device can generate reply to this packet? The device who is using this IP address, yes or no? Because destination IP address is 10.1.1.1. If I am receiving a packet where destination is 10.1.1 and I am also using same IP address, then definitely I will generate reply because this is a packet for me. But let's say if my IP address is different and I am receiving a Gracious ARP where destination is different, right? Then I will drop it. I will simply drop it because it is not for me. If someone will send letter at my address and on the envelope, let's say name is different, name is not Praful, then I will not accept it. I will not open the envelope because this letter is not for me. So it is going to PC2 is not going to open it, right? At layer 3, it will check the destination is 10.1.1. Okay, my IP address is different. This is not for me. Drop it. If destination is PC2, then PC2 is going to open the ARP packet. In ARP packet, there will be code like ARP, Gracious ARP request. So, okay, someone is sending ARP request. Let me generate the reply. It will generate reply. If PC2 will generate reply and when PC1 will receive reply message from PC number 2, it will give you error that this IP address is duplicate. It will not give you information that which machine is using this IP address, but if it will give you just this error that this IP address is duplicate.
Okay, so this will happen when we are assigning static IP and then connecting the
In both
PC to
scenario,
the network, or is it
whenever we assign
DHCP
IP address
also?
to PC or any interface, right, to router interface, to switch interface, on any interface, doesn't matter where you are configuring IP. If you are configuring IP address, first machine will generate a Grace ARP and it will check that IP address is unique or not.
That Grace ARP will automatically generate, or we
Automatically.
need to generate it?
Automatically. We don't need to do anything. We will configure only IP address. Let me show you here. Here in packet tracer, I am going to take one PC here and I am going to connect this PC to one switch, let's say, just for the testing purpose. Done. I have connected the PC to switch, and here I am going to on simulation mode so that we can capture the packet. And now I am going to assign one IP address to this PC. On this PC, I am going to desktop IP address, and here let's say IP address is 10.1.1.1 and subnet mask this one. See, are you able to see this packet here? Just I have assigned the IP address, automatically PC1 have generated one message. Yes or no? This is Gracious ARP. If you will open this message, you can see here. This is which type of message? Target IP address is the IP address of this machine. Here we are not able to see which type of message it is, but if you know the code, you can understand that it is an ARP packet. Here opcode value is 0x001. This is the type code of Gracious ARP protocol.
Okay, means 1, right? Okay. In decimal.
Yeah.
In decimal.
1 minute, guys. Sorry. Thank you. 10.1.1.2 and 255. This is subnet mask. See this Gracious ARP. This PC will forward it to switch, and switch will forward one copy to all PC. Right? And no one is going to generate reply. All PC have dropped this packet. Why? Because in the packet, if you will open the packet, in the packet you can see destination or target IP address is 10.1.1.2. No one is using this IP address, and this PC will wait for 2 seconds. Within 2 seconds, if it will receive reply, it will give you the error that this IP address is duplicate. But after 2 seconds, if it will not receive any error, then it will assign the IP address to their interface. Here we can check IP config. You can see this IP address is assigned to this interface. Getting my point?
I mean, the IP address is assigned to the machine, right? Not to the interface, right? That this machine.
To the interface. We cannot configure IP address on machine. Interface will have IP address or MAC address, right? Your actually interfaces are going to talk to other device, not device actually.
Yeah. That NIC, network interface card.
Yes,
that's what
network
you're saying.
interface card.
Okay.
So this GRP, right? So which the PC is sending to the switch, and then it broadcasts to the other connected PCs in the same. So is it an L2 traffic, right? Not L3 traffic,
Right. It is definitely.
Okay.
In the traffic, you can see there is no L3 information. We have R packet, after that L2 header, Ethernet header. We don't have layer 3 information here.
So assuming in that case, if let's say in the same switch, if we have few other systems also, I mean endpoints also connected in a different VLAN, so the switch will not broadcast to the thing in the other VLAN.
No,
so
definitely
whatever
not.
the same VLAN, it will be broadcasted. Correct me if I'm
Exactly.
Okay.
Because it is a broadcast message, it can never cross broadcast domain. Getting my point? So broadcast domain is what? Domain where broadcast message can be travel. If we have configured the VLAN, that means we have separate the broadcast domain. So one broadcast domain message cannot cross their domain, right? Their boundary cannot enter in different domain.
Okay, so slightly more deeper. in case, right, if I mean in a practical level,
Hmm.
and usually in the enterprises we will not have single switches, we will be having multiple switches. Let's
Yeah.
assume in this scenario, rather than one switch, if we have, let's say, 5 switches which are
Okay.
connected, interconnected, and then maybe we have around 10 of 20 systems, whatever, connected across all the other switches but in the same VLAN. So whatever thing that we have I mean the GR packet, gets initiated from this PC3 will be communicated to all the endpoints in connected to all the switches in the same VLAN. Correct me if I'm wrong.
Correct.
Okay.
But we will not design network like this, na. That's why we have a proper design, architecture of a network. That network design should be in layer, in 3 layer: core layer, distribution layer, access layer. And if we have lots of switches, then we will have different multiple VLAN there, right? If my broadcast domain is large, brother, that means there is some problem in network. After whenever you will configure IP address on any machine, it is going to generate one R packet. Whenever machine need to communicate to a device and machine don't have MAC address, it will generate ARP request message. So if you're let's say 1000 computer are there in single broadcast domain, so 1000 computer will receive broadcast message again and again. And whenever PC is receiving ARP request, let's say this PC have received one ARP request message, it will decapsulate the layer 2 header. After that it will check the layer, in ARP message, what is the message, what is the destination, and then it will drop it. So whenever machine will performing encapsulation or decapsulation, adding extra information or removing extra information, means PC are using their CPU.
Means resource utilization will be more, right?
Yes.
It will use.
Getting my point? Is it clear? Then CPU
Yeah.
utilization, maybe CPU utilization of a device can be high, or CPU utilization of a switch can be high, because switch also need to receive 1000 packet and need to forward 1000 packet. Getting my point, guys? So that's why we will not design network like this, that we will connect 5 switch together like this, and then we will connect thousands of computer with switch, and all PC will be in single VLAN. No. Let's say here we have 4 devices. Now I will suggest to configure 2 VLAN on this switch and separate the broadcast domain, so that whenever these 2 devices will generate any broadcast message, will not receive by PC number 2 or PC number 3. And whenever PC 2 or 3 will generate any ARP message, it should be not received by these 2 PC. That's why we have concept of VLAN. We will understand in upcoming day. Don't worry. Okay.
Yeah, okay, sir. Thanks for it. No, the reason is I'm actually trying to, correlate with the practical infra we have, because this is not just out of assumption. I'm telling you, because in our infra, right?
In
So
infra,
as you,
your
as you were
infra
telling-
design is like how your
so
switches
that's
are
a, no,
connected.
we have core layer, distribution layer, and then
Okay.
access layer.
Let's
So,
say this is core layer.
Yeah.
Two
and the
switch
core
are there?
layer core layer, distribution, and then access layer.
How
So
many
we
switches
have-
are there at core layer?
Sorry, in core layer.
Yeah, how many switches are there?
No, in core layer we have 2 + 2 4 switches in stacked VSS.
Okay.
And distribution we have around 16 switches.
Okay.
And access switches, right? I mean, it again depends, right? Because for one floor we will have 3 access switches, at least minimum 3
So
or 4.
I am damn sure your all access layer switch is not in same VLAN.
That's it, sir. So I mean, we have multiple access switches getting connected to the distribution and then to the core. And in our infra, right, normally we will not create the L3 in the access layer. We will create the L3 only in the distribution layer.
Exactly.
Let's say we have one building 5, building 8, and all, right. So we have specific to project VLANs. Additionally, we will also have few VLANs like general VLANs, wherein that VLAN will have only access to the normal intranet and then to the access to the internet. So what will happen is that, right, users will request for VLAN change, and then we will actually consolidate, like for this building we will have this VLAN, this building, this VLAN. That's how we are designed. But
Okay.
sometimes when the IP shortage is there, right, when the DHCP scope is not enough, we will actually try to utilize we will try to change the VLAN of the next building thing. So that's how we normally do it in the regular operations thing. So I'm trying to correlate in that way, because in that case, right, what will happen is that the L3 will be created in the distribution layer, but the same that the respective VLAN number, right, that L2 VLAN will be
Your
spanned in a
distribution layer
particular.
switch will never, your distribution layer switch will never receive broadcast message. First of all, why your distribution layer switch is going to receive broadcast message?
That's
You have
why.
already separated it.
Okay, no, that's why. See, distribution, access, and core is something Cisco designed. But let's say if we need to create a VLAN, right, 10.1.1.1/24. So
Okay.
that particular L3 has to be created somewhere, either in a switch or in a firewall. Let's assume it is going to
Exactly.
be created in a switch. So now switch means two options are there. Either the switch, I mean the L3 can be created in the access layer switch, or else it can be created in the distribution. So in our infra, the L3 will be created in the distribution, not in the access. And what will do that under one distribution, let's say if we have one building one, B1 building means in building one we will have around 20 or 30 access switches, because different flows are connected and we will come connected via the fiber. So right, we will have around some let's say general VLAN, we will have some 5 to 6 general VLANs or 10 general VLANs. So all the 10 general VLANs L3 will be created in the distribution, and the respective VLAN number will be spanned across all the ether channel. I mean this one which is connecting to the access layers. So in that case, if a user is coming and asking me please change my network to general VLAN, then I will get a MAC, and then I log into the switch, which switch it is coming, and then I'll change the general VLAN. So once I change the general VLAN, right, automatically it will fetch the IP from the IP helper address, which is none other than the DHCP scope. So when the DHCP issues a IP address to the endpoint, right, that is the laptop or desktop, whatever. So now I'm trying to correlate with the GR concept that you have teach us. So I'm thinking like whether this will actually so from the endpoint to the access layer, it is the L2 traffic, and only it will fetch the L3 from the distribution. So when in that same distribution, we will have multiple L2, access switches connected, and same VLAN is spanned across the other access switches also. So obviously it will be this GR will be spreaded across the same VLAN, which
VLAN.
is spread across different L3 switches.
Mm-hmm.
That's why I was just trying to correlate with my infrastructure.
Okay.
Thank
Good.
you very much.
Good. Sometime we will discuss about your infrastructure as well. Okay, we will see your configuration, your design also, right? After discussing first syllabus. Okay, at the end we will discuss your infrastructure. How if you will share the blueprint of your network, you can draw the diagram in page, or you can share with me, so that we can discuss here, or so that we can give real time example to others people as well. They can also understand how in real time network look likes, and how routing protocols or switching protocols is going to work.
Yeah, okay, sir. I'll share the design by masking the other details.
Okay.
Okay, thank you.
Okay, so Gracious ARP is clear to all. GARP. GARP. Very simple. It is used to check duplicate IP address. Okay. Now next thing is, okay, here let's say both machine have checked that IP address is not duplicate. After that, next step is maintaining a ARP table. PC1 and PC2, both PC will have one ARP table. Both machine is going to maintain a ARP table. Guys, inside the ARP table of PC1, there will be some information like IP address of PC1 and MAC address of PC1. And here let's say this is ARP table of PC2. This is ARP table of PC2, and this is ARP table of PC1. ARP table, and here ARP table. What will be the information inside the ARP table of PC1? their IP address and their MAC address. IP address of PC1 is 10.1.1.1 and MAC address of 10.1.1.1 is 0A. In the same way, in the ARP table of PC2, there will be one entry 10.1.1.2 and MAC address of this IP address is 0B. That's it. And you are running this command ping 10.1.1.2, ping 10.1.1.2 in the CMD of PC1. PC1 will generate one ICMP request message. ICMP echo request. We are saying ICMP echo request. And ICMP echo request type code is 8. ICMP echo request type code is 8. Here I can show you. See, I have two PC. First of all, on PC number 1, I am going to configure one IP address. Let's say here this is PC4. PC4 IP address is 10.1.1.1. Subnet mask is 255.255.255.0. Let's say done. So see, I have configured the IP address. That's why this machine have generated Gracious ARP. It will forward to PC2. PC2 will drop it, right? PC2 will simply drop it, and PC4 will assign that IP address to their interface. In the same way, I am going to configure one IP address to PC5 also, 10.1.1.2 and 255.255.255.0. Done. I have configured the IP address on both machine. Both machine will have ARP table. Now, if you will check ARP table of PC1, so this is window machine, and as I told you that in window machine there is no entry, because window machine is not going to make entry of their own IP address on MAC address. So that's why here on PC number 4 you can see ARP table is empty, no ARP entry found. And in the same way, PC number 5 will also have 0 entry, ARP -A, no entry in the ARP table. Okay, so if I will ping from PC4 to PC5, first of all, it will put PC4 will put the ICMP traffic on hold, and it will generate ARP packet. See here, I am going to ping 10.1.1.2, ping 10.1.1.10.1.1.2. See, PC4 have generated 2 packet. Why 2 packet? One is, see here now, one is ARP packet and one is ICMP packet, and it is ICMP request message. So if I will open this message, you can see in this is IP header and this is ICMP information. Here type code is 8, 0x08. That means it is an ICMP request message. It is an ICMP. This is ICMP message. In ICMP message, you can see these are the information. This is the actual data, and after that this is IP header. In IP header, source IP is the IP address of PC1, destination IP address is the IP address of PC2, and in the protocol field value is, where is protocol field? Protocol field value is 1, that means protocol number of ICMP. Protocol number of ICMP protocol have hand over this to IP protocol, so that's why here is information of upper layer protocol, you can say upper protocol, that which protocol have hand over the actual message to IP protocol, ICMP. So in the protocol field there is information of protocol number of ICMP. After that, if you will open ARP message, you can see ARP message. This message is used to find MAC address of 10.1.1.2. 10.1.1.2, because see, source IP is 10.1.1, destination IP is 10.1.1.2, and source MAC is MAC address of this PC4 and destination MAC is broadcast, all F. Is it visible?
Yes.
Okay. So destination MAC is broadcast, means at layer 2 again this is a broadcast message. And if you want to see what is the information inside the ARP message, so in ARP message you can see this is ARP message. In ARP message there is opcode. Opcode value is 1. As I told you here, opcode value 1 means it is an ARP request message. So if opcode value is 1, that means it is an ARP request message, right? And here source IP address is the IP address of 10.1.1.1. This is not IP header, guys. Again I am telling you, this is ARP packet. And target MAC address is 0000. I don't know. Whenever machine don't know what is the destination MAC address, target MAC address, it will set MAC address 0.0.0. And target IP address is the IP address of PC5 10.1.1.5. That means I am finding the MAC address of this IP address. This is the actual statement of this ARP request message. Just tell me what is the MAC address of this IP address. Now who will generate reply? The machine who is using this IP address, yes or no? And again at layer 2 it is broadcast all F. And in type what is the value? 0x0806. This is type code of ARP protocol. Means ARP have hand over actual protocol is ARP who have hand over the data to Ethernet, means to layer 2, means ARPA protocol. At layer 2 ARPA protocol is responsible, right? So to ARPA protocol, we who have hand over the actual information? ARP protocol. So this is the information here in Ethernet header. Okay, when this PC will forward this message, ARP request message, this PC will generate ARP reply message. This is Gracious ARP packet, right? Don't focus on this message. PC5 have generate ARP reply message. If you will open ARP reply, you can see opcode is this time 2. Opcode is 2. And target MAC address is the MAC address of PC4. This is MAC address of PC4. Here when PC5 will generate ARP reply, source MAC will be the MAC address of PC5. Destination MAC will be the MAC address of PC4. This is not broadcast message. This is unicast message at layer 2. And in the ARP packet also you can see target IP, target MAC address, target source IP address and source MAC address. All are unicast. Only difference is opcode. Opcode is 2. And at layer 2 again, now this time it is an unicast message, not broadcast, because this PC have already information about the MAC address of PC4. PC5 know what is the MAC address of 10.1.1.1. How PC5 know this? Because if I will show you the ARP table of PC5 now, you can see there is one entry. The MAC address of 10.1.1.1 is this one. How PC5 have came to know that this is a MAC address of 10.1.1.1? Who will explain this?
So can you repeat the question again, sir?
Question is, see, PC5 have information about the MAC address of PC4. This is the IP address of PC4 10.1.1.1 and this is the MAC address of PC1. I am asking you that how PC5 came to know that this is the MAC address of this IP address.
No, in the first when PC4, I mean when we ping from PC4 to PC5, the ARP information was already shared, right? Which you showed in the
Right.
other packet.
In that request message only it will.
When PC5 will receive request message, ARP request message from PC4, in the ARP request message source IP will be 10.1.1.1 and source IP will be, source MAC will be this one, right? So PC5 is going to make one entry in their ARP table also. Whenever PC will receive any frame, any message, right, from any device, it will update their ARP table. It will learn source MAC address with source IP address, okay? And PC5 have generate ARP reply also, so PC4 also should have this the MAC address of PC5 10.1.1.2 means MAC address of 10.1.1.2. Where is PC4? Here it is. What happened here?
But it should get that response, right? After that only that table will be updated.
PC4, na?
Yeah.
Yeah, PC4, because if let's say PC4 have received different message from PC number 5, then PC4 don't need to generate ARP message. It can directly generate ICMP traffic, ICMP message. Yes or no? Because in the ARP table there will be one entry, the MAC address of PC5 is this one. So if first PC will check when PC, I have run this command na, ping 10.1.1.2, PC4 will generate ICMP request message and it will hand over to IP protocol. IP protocol will attach source IP, destination IP, and after that it will hand over to layer 2. Layer 2 will attach source MAC, destination MAC. So to find the destination MAC, it will check ARP table. If entry is not available in the ARP table, then only it will generate ARP request message. Then ARPA protocol will call to ARP protocol, please find the MAC address of this IP address. Okay, if entry is there in the ARP table, then definitely machine is not going to generate ARP request. Okay, anything else? Any other question?
So Praful, here you mentioned that first will be that ICMP packet will generate, then the R packet will generate, right?
Right.
So suppose first PC4 has generated ICMP packet, then it will
Okay.
receive an acknowledge from PC5, right? Or simultaneously it
No,
will
it
generate
will
R
not
package
forward.
as well.
It will only generate. Like, see here, what will happen? Here,
Okay.
this PC will generate ICMP echo request, right? Type value will be 8. After that, ICMP protocol will hand over it to IP protocol. IP protocol is going to add one IP header with this packet, right? One header. In that header, source IP address will be 10.1.1.1. Destination IP will be 10.1.1.2, and protocol, in protocol field value will be 1, right? It will add this header IP protocol, and after that IP protocol will hand over this all message to all information to layer 2. Now layer 2 is going to add source MAC, destination MAC. Source MAC is very simple, 0A, and for destination MAC it will check ARP table. If in ARP table entry is not available, that means ARPA protocol cannot encapsulate the frame because destination MAC is missing, is not available. So it will put these all entire information on hold because destination MAC is not available. It will put this information on hold and it will generate one ARP request message. It will generate one ARP request message. Hold, and after that it is going to generate one ARP request message, ARP request. Okay, now in ARP request, ARP protocol will generate ARP request, and ARP protocols work at layer 2. So directly it is going to ARP protocol is going to hand over this ARP message to layer 2 header, means ARPA protocol at layer 2 data link layer, right? ARPA protocol will add what? Source MAC address 0A, and destination MAC address in the ARP message will be always broadcast, all F. Okay, and then there will be type field. In type field information will be what? 0x0806. This is type code of ARP protocol. Who have hand over the message to ARPA protocol? ARP. So this is the information of ARP. And after that, first PC will forward this message, and then PC will forward. When a reply will come, after that it is going to again encapsulate. See what will happen. It will, PC1 will forward this message to PC2. PC2 will generate one ARP reply message. When PC2 will receive this message, PC2 will generate one ARP reply message, ARP reply message with type code 0. Sorry, reply message 2 with type code 2. After that, it will again ARP protocol will hand over this message, this ARP request reply message to ARPA protocol at layer 2. At layer 2, it is going to add source MAC address. Source MAC address will be 0A. And what will be the destination MAC, guys, here? 0B, because now PC2 have already knowledge that MAC address of 10.1.1 is 0B. because it have just received ARP request message, right? So destination MAC will be 0B, and again in the type field, type code will be same.
Sir, when the ARP reply comes, the source MAC will be 0B and destination will be 0A, right?
Sorry, this will be, yes,
Okay,
yes,
thanks.
0B. Source MAC will be 0B, 0B MAC address of PC2, and destination MAC will be 0A. Yeah, sorry. Okay, after that the PC2 will forward this message to PC1. Okay, now when PC1 will receive this message, it will update their ARP table. Their ARP table, in the ARP table it will make one more entry, 10.1.1.2, and MAC address is 0B. And when PC2 will receive the ARP request message, PC2 is also going to update their ARP table. The IP address is 10.1.1.1 and MAC address is 0A. 0A. Okay, now PC1 have MAC address of 10.1.1.2. So this time again it is going to encapsulate the actual message. This process happened. Now PC2 have knowledge about the MAC address of PC2. It will put the MAC address, destination MAC address is 0B, 0B, and type in the type code, in the type field, type value will be what? Type value will be 0x0800, because this time to layer 2 who have hand over the actual message, IP protocol. Yes or no? This time IP protocol have hand over actual message to ARPA protocol. So type code of IPv4 address is this one, 0x800, right? And now PC1 is going to forward this actual ICMP message to PC2. PC2 will generate what? ICMP reply message. In ICMP reply message, type code will be 0. Like this it will work. Is it clear now, or still anyone have confusion? Clear or confusion? Tell me, guys. By transport layer. Oh my god, recording was stopped. Oops. Okay, nothing important we were discussing, right? These are basic things, you all already know this. Yes or no?
Sure.
So now here let's say I have two router, R1 and R2. Or router 1 only, let's say. Router 1 is receiving one data. It have just received this data at data link layer. Let's say physical layer have hand over the data to router number 1 at data link layer. At data link layer, can anyone tell me how router 1 will come to know that I need to hand over this to which protocol? Actually data link layer have to hand over it to upper layer protocol, yes or no? Data link layer will check what information? Destination MAC. If destination MAC is the MAC address of router 1, it will check which field. Just think and type.
Type code.
See, let's say router 1 is receiving a data in this is data. This is application layer data. At application layer, it is data of HTTP. Okay, let's say this is data of HTTP at application layer. After that, this is application layer. At transport layer, there will be source port and destination port. Yes or no?
Yes, sir.
Source
The
port will be
recording
what?
on.
Any random, yeah, random port number 10, let's say 25, and destination is 80. Okay, this is transport layer. After that there will be network layer. At network layer there will be how many information? Source IP, let's say 10.1.1.1. Destination IP, let's say 10.1.1.2. And then protocol field. Protocol field, what will be the value in protocol field? Oh, 6. Very good. 6. And after that it will hand over to lower layer. Lower layer at data link layer there will be source MAC address, destination MAC address. Let's say source MAC is 0A and destination MAC is 0B. And after that there will be type. What will be the type code?
Type code, sir.
Who have hand over this packet to data link layer? Which protocol is working at layer 3? IP. IPv4. So type code of IPv4 0x0800.
08. Okay.
Right. So when router 1 will receive this packet, first of all, this frame, first of all, router 2 is going to check this information, destination MAC address. If destination MAC address is my MAC address, then only I will accept it. So let's say destination, this is the MAC address of router 1, receiving interface MAC address, right? So it will accept it. After that, router 1 is going to check that, okay, this is the packet for me, but to whom I need to hand over at upper layer. For that, it will check this type field. In type field, value is 0x0800. Okay, this is type code of IPv4. It will remove layer 2 header and it will hand over the packet to network layer, to IP protocol at network layer. IP protocol will check destination IP address. Destination, if destination IP address is my IP address, then only I will accept it. Otherwise, I will drop it. So yes, destination IP address is my IP address. So let me check protocol field. Okay, protocol value is 6. That means I need to remove this header and I need to hand over the segment to TCP protocol at transport layer. What TCP protocol will check? Destination port. Okay, destination port is 80. Let me remove this header and let me hand over the actual HTTP packet to HTTP protocol at application layer. This is how it is going to work. Okay. At application layer, we called HTTP data to data. At layer 4, what we call it? Segment. At layer 3, what we called it? Packet. At layer 2, what we called it? Frame. Guys, if still you guys have doubt, tell me, I will give you one more example. Because this is very important. You know, in BGP also, if you are not comfortable in these things, you cannot understand that why BGP neighborship is stuck between two routers. Is it clear, or should I give one more example? Yeah. One more example? Okay. Let me give you one more example. PC1.
Just give one more example, please.
Okay. See PC1, PC2. MAC address of this PC is again 0A and MAC address of this PC is again 0B. IP address of this machine is again 10.1.1.1 and IP address of this machine is again 10.1.1.2. 10.1.1.2. Okay. Here let's say on PC number 2 one service is running, that is HTTP. And domain name of this server is HTTP server. Let's say here domain name is www.pmnet .com. Okay, one domain, this service is running on this server. Okay, fine. And this PC, when you will open the browser of this PC and you will type www.pmnet.com, what will happen? This PC will generate one HTTP message. It will generate one HTTP request message. HTTP message. Okay, after that, application layer will hand over it to which layer? Directly, let's say transport layer. What transport layer will do? Transport layer will add source port, destination port. Source port is, let's say, 0, 1, 2, 5, and destination port is, let's say, 80. Okay, this is transport layer header. At transport layer, what we called it? This is what? This is a segment. This is nothing but a segment. And then transport layer will hand over this segment to which layer?
Network.
Network layer. Network layer have, let's say, receive one segment, and with this segment, network layer will add what? IP header.
Destination IP.
IP header. Okay, so let's say this is IP header. In the IP header, there will be what information? Source IP,
Destination.
that is 10.1.1.1, destination IP, that is 10.1.1.2, and
Protocol. Port
and protocol. Very good. In protocol field, what will be the value?
6.
6. Protocol number of TCP. This particular thing is called what? Packet. This particular thing is called packet. And network layer will hand over this
why
packet.
it is 6? Protocol 6?
6 is the protocol number of TCP. Who have hand over the actual segment?
Okay.
Who have hand over the segment to IP protocol? TCP, na?
Yes, sir.
TCP protocol,
Yeah,
na? So
got it,
that's
got
why
it.
there is protocol number of TCP. Okay. After that, data link layer. Data link layer have received one packet. Very good. Packet. And data link layer will add one header with this packet. Yes or no?
Yes.
In that header, there will be information of source MAC, destination MAC. What will be the source MAC? 0, A, destination MAC, 0, B, and type. In the type, what will be the value?
1. 0.
But
800.
yeah, 0x 800, this value. Okay, and this particular thing is called what? Frame. And then data link layer will hand over this frame to lower layer, frame to physical layer, and physical layer will convert it to bits, and after that it will forward this bits into bits to, it will convert this frame into bits and into signal, and after that it will forward from the link, it will transmit on the link. Yes.
Yes.
When PC will receive what? PCB will receive one frame. First of all, it will receive bits, definitely bits, and physical layer will convert that bits into frame, and it will hand over the frame to data link layer. Data link layer is going to open this frame. So inside the frame, what is the information, guys? Inside the frame there is one packet. Yes or no?
Yes.
Inside the frame there is one packet, and along with packet there is one header, right? In the header, what is the information?
Source address. Destination address.
Along the frame, this is detailed information of. Okay, here there will be source IP address 10.1.1.1, destination IP address 10.1.1.2, and then
Source MAC address.
no source MAC address. Sorry, here it will be source MAC address. Sorry, source MAC address 0A and 0B,
Yes.
and then type.
Type, because that is a ICMP packet, is it?
No, this is not
IP.
I mean,
IP.
Who have hand over actual packet
okay.
to data link layer? Who hand
Yeah.
over this packet to data link layer?
IP.
IP protocol, na?
Yes.
So there is type code
Yeah,
of
yeah.
IP.
Okay.
Okay, these will be the information inside the frame,
Frame.
right? Just PC have opened the frame in detail. It will check destination MAC address. If destination MAC will match, then it will check what type field. In type field value is what? 0x800. So it is type code of IP packet. It is data link layer is going to remove this extra information. It will remove this extra information at layer 2, and it will hand over the packet to upper layer. It will hand over this packet to upper layer. Which layer? Network layer. Network layer will open this
Oh,
packet
sorry.
in
Net.
detail.
Yeah,
What
yeah.
is the information inside this packet? Who will explain what is the information inside this packet?
Source IP, destination IP, and protocol.
Yes, very good. There is source IP address, that is 10.1.1.1. Destination IP, that is 10.1.1.2, and protocol. In protocol value is 6, right? So network layer will check destination IP address. If destination IP address will match, it will check what protocol field. Okay, protocol value is what? 6. So network layer IP protocol will remove this header. Which header? This header. And it will hand over the segment. Actually, this is not
But that
packet
is segment.
inside. This is segment, na? This is segment, not packet. This is segment. Inside the packet, there will be segment. Segment, right? It will hand over the segment to upper layer protocol. Upper layer protocol. Now, upper layer protocol, at upper layer, there are multiple protocol. To which protocol? So see that protocol value. Protocol value is 6. That means to TCP protocol. So it will hand over this segment to upper layer protocol. And upper transport layer will open this segment in detail. What is the information inside this segment?
Source port.
HTTP data. There is HTTP data, yes or no? HTTP data inside the segment. If I will talk about inside the segment, there is HTTP data plus there is HTTP data plus
TCP head.
source port. Source port will be 1025 and destination port is 80. Okay, so transport layer will check simply destination port. Destination port is what? 80. So it will remove this header. Transport layer will remove this header and it will hand over the actual data to which protocol?
HTTP.
To HTTP protocol at application layer. It will hand over this actual HTTP data to upper layer protocol to application layer, right? This is how packet flow. This is packet flow between two computer in case of HTTP. And when this PC means PC0 is encapsulating the data, at each layer it is adding extra information, right? Like transport layer, it have added source port, destination port. At layer 3 it have added source IP, destination IP, and protocol. At layer 2 it have add what? Source MAC, destination MAC, and type. And in the same way, receiving machine is removing that extra information at each layer. Yes or no? Yes or no?
Yes.
So adding extra information with data is called encapsulation, and removing extra information with data is called decapsulation. Encapsulation means nothing but adding extra information with actual data, like PC1 is doing here. adding extra information at each layer, and PC2 is removing that extra information at each layer. That is decapsulation. Is it clear? Is it clear now, or should I give one more example? Hello, one more example, or is it fine now? Packet flow is
Yeah, for
clear.
me now.
Yeah, Sanjeev.
Yeah, it is clear for me, Prof.
Okay, Sanjeev, good. And what about others?
That's clear, Ji. Thank you.
Clear.
Clear, sir.
Good. So now again, let's come to our application layer protocol. Now let's understand some application layer protocol. Okay, here I am going to design one network in packet tracer. This is my, let's say, switch, and this switch is connected with some server. Let's say here we have DHCP, DNS, or any other server. Let's say this is DHCP server. This is DNS server. This is HTTP server, and this is FTP, or let's say that is fine. 3 server is fine. Okay. And now we have some computer here. Okay, and these computers are also connected with, let's say, one another switch. And for now we don't have any router between these two switch, but later on we will have lots of devices between these two switch. Okay, for now let's say we don't have any device. These devices are connected like this. These PC need IP address from DHCP server, and after that these machines should be able to access HTTP server. And let's say on this HTTP server domain name is www.pmnet.com. Here domain name is www.pmnet.com. Okay, this is my DNS server, and let's say IP address of this DHCP server is 192.168.1.0/21.1. Here IP address is, let's say, 192.168.2.1.2, and here IP address is, let's say, 192.168.1.3, right? And these PCs need IP address from the same range. Okay, we will configure everything step by step. First of all, we will configure DHCP. First of all, let me configure IP address on all server. Okay, on DHCP server, let's say IP address, I'm going to configure here IP 192.168.1.1. subnet mask is this one, and default gateway is, let's say, 192.168.1.100. for now, just suppose this is the default gateway IP address, and DNS server IP address is 192.168.1.2. I have defined all the IP addresses on DHCP server. Let me assign IP on DNS. On DNS server, I am going to configure IP 192.168.1.2, and the gateway is 192.168.1.100, and DNS server IP address is same. Okay, we have configured everything. Let me configure IP address on DHCP HTTP server now. 192.168.1.3, and gateway is 192.168.1.100, and DNS server IP address is 192.168.1.2. okay, we have configured the IP address. Now we are going to enable DHCP service on this server. First of all, let me enable DHCP service. To enable DHCP service, just you need to go in services, and in services you will find this option DHCP here. By default this service is off, you can turn it on, and then you need to create one pool. So here default gateway IP address in pool. What default gateway you want to provide to client machine? let's say 192.168.1.100, same IP address. Or when you will understand IP addressing and subnetting, right, then guys, you guys will get familiar with this type of default gateway and IP addressing. What is default gateway? Okay, we will discuss these things, don't worry if anyone have confusion. Then DNS server IP address. What IP address of DNS you want to provide to client? So the same IP address of DNS 192.168.1.2. Then starting IP address from the range. Here you need to define the range of IP address. From that you want to assign IP addresses to the client machine. So I have already used 3 IP address, 192.168.1.1 to 1.3. So I am going to say starting range is 1.4. okay, subnet mask will be this one. Okay, nothing, everything is fine. Let me save it. Okay, DHCP's configuration is done on the server. Now on this DNS machine, I am going to, now I am not going to configure DNS, later I will configure DNS. Okay,
Sir, one
Here-
small thing, and the DHCP
Yeah.
scope, it should be, it was mentioned 512, so it means /23 actually, but we have configured only /24.
here we can change the value. Let's, okay, that is fine, brother. We will not get any error, but we can calculate the user, exact user, and we should provide that, but this is not real time, you can ignore it. Okay, for now.
Okay, sir.
Here DNS, I will configure DNS service later. Before that, I am going to configure HTTP service over here on this server. So here go to services, then HTTP service, and by default HTTP is enable. Here if anyone know HTML, so you guys can do coding over here, but by default this is welcome to, I think, Cisco Packet Tracer. Welcome to Cisco Packet Tracer, and these are the highlighted heading. So you can change it, or we can here set, let's say, welcome to not Cisco Packet Tracer PM networking. This is website coding, we are not going to learn it. PM, welcome to PM networking. I have defined it here, save. Okay, now first of all I am going to check that these devices are able to get IP address from DHCP server or not. Okay, so let me here check, go to desktop, then IP address, and here I am going to click on DHCP. Let me check. Yes, this machine is able to get IP address from DHCP server, right? IP address of this machine is 192.168.1.4, and before assigning the IP address on this machine from DHCP, I am going to discuss the messages of DHCP here, right? For that, let me open simulation mode here, and now I am going to click on DHCP section now. Okay, once I have clicked on DHCP, see this machine have generated one message. This is DHCP message, right? This is, guys, DHCP discover message. DHCP works on DORA process. Okay, or maybe tomorrow we will discuss DHCP, leave it for now, or maybe after IP addressing it will be better if we will discuss DHCP protocol or application, all application layer protocol. For now, you can see this is first message of DHCP. First of all, client will send one message to DHCP server, that is discover message, and this machine don't know anything about DHCP server, so it is going to broadcast this message, right? If you will open this message, you can see this message is broadcast at layer 2, right? This message is broadcast at layer 3 also. Okay, this is DHCP discover message. It will forward this message to switch will forward to other switch, and then it will forward to all server, and DHCP server will only generate reply message, and reply message is called, this is ARP message, not reply message. Here is DHCP second message, where it is, I think this one. This is DHCP second message, that is offer message. Server will offer the IP address. Here you can see this is the DHCP message. In DHCP message, it is providing the IP address of client machine 192.168.1.5, then server address, then relay agent relay agent is not available and you don't know anything about relay agent, don't worry. But in this section we will have DNS server IP address also. We are not able to see, I think. DNS server IP address is where it is. Maybe we are not able to see in this packet capturing, but I will show you in the discover message. There will be DNS message also, DNS IP address also. It will share DNS IP address also, right? This is discover message. And discover, when client machine will receive discover message, then again it is going to send one message of DHCP, that is request message. Now it is going to request that can I use 192.168.1.5. if you will open this message, it is requesting for this IP address. Okay, request message. And finally the last message in DHCP is that server is going to send, that is acknowledgement message. This is the acknowledgement message of DHCP, and when client machine will receive this message, it will assign that IP address to their interface. Okay, this is the function of DHCP. Here just I am giving you one overview. There are 4 types of message in DHCP. One is discover, second one is offer, third one is request, and fourth one is acknowledgement. After exchanging these 4 messages, there are some broadcast message and some unicast message. We will discuss about that also. Okay, and finally you can see here this PC have got one IP address from DHCP server. In the same way, this PC can also get IP address from DHCP server. Let me click over here. Yes. Okay, and all PC have get IP address, subnet mask, default gateway, and DNS server IP address. Now if here in the browser, if I will type www.pmnet.com, www.pmnet.com, will I get access of this website? No, I will not get access of this website. Why, guys? Because I am trying to
DNS not
access this
configured.
website through, yes, DNS is not configured. This client machine is going to ask to DNS what is the IP address of this domain name. Here I can access the website through IP address. I can put IP address of website 192.168.1.3, and you can see I am able to access this server, this web page through IP address, but I am not able to access through domain name. So if you want to access through domain name, you have to configure DNS. So on DNS server, I am going to again enable DNS services here. So go to services section, and here you can see you will find DNS. In DNS service is by default off. Let me turn it on. And now here domain name, define whatever domain name you want to define. If you will define XYZ and IP address is 192.168.xyz.com, and I am going to tell IP address of xyz.com is 192.168.1.3. so whenever this DNS will receive any request for this domain name, it will provide this IP address. So I am going to configure which domain name, www.pmnet.com, right, this IP address, and add. So now we have one entry on DNS server. The domain name is this one, pmnet.com, and IP address is 192.168.1.3. Okay, now if someone will request for the IP address, this DNS server can provide IP address. And now if you will access your website through domain name, you can access your website through domain name also, because DNS is now working fine. So we will discuss these protocol like DNS, DHCP, and Telnet, and other application layer protocol in detail also, but this is just an overview. www.pmnet.com, and you can see I am able to access my website through domain name also, right? So here DNS is actually resolving the IP address from the domain name, from the fully qualified domain name to IP address. It is DNS is like your phone book, your contact list. It is difficult to remember the IP address of all website, but it is easy to remember the name of website. It is easy to remember my name Praful, but it is difficult to remember my mobile number. Right? To remember the number is difficult as compared to name. That's why we have DNS service. Okay. Is it clear to all? The basic overview of DNS and DHCP.
So Praful, suppose once the computer receiving answers from the DNS, suppose they are receiving the uh, DNS name and resolution from DNS server, then that switch will also manage that table in it, right? So next time
No,
if
no.
any other system will join that network, switch will reply directly, or the same process will happen again.
No, switch is not going to learn, domain name and IP address. This PC itself going to learn the IP address and domain name in their cache memory. It will store the information in their cache memory. Right? And if you have here a router or networking layer 3 networking device, so you can tell to layer 3 device that you should maintain the cache memory. By default, these devices are not going to store any information of. Actually, even switch is not going to open the message of DNS. Switch will open only layer 2 information. When we will understand the switching, you will see how switch is going to forward the traffic. Okay, it will not open layer 4 or layer 3 or layer 7 information. It will open only information till layer 2, and it will take the forwarding decision. Okay.
So suppose if there is any other computer will join that network in
Mhm.
PC 8, 9, 10, suppose PC 11 has joined. So if it asks the DSCP server, then the whole process will happen again. The switch will broadcast that
Yeah,
message, and
exactly.
then DSCP will provide that I. Okay.
Broadcast message, not broadcast message, no, unicast message. Are you asking for a
Yeah,
DSCP
yeah.
packet or DNS packet?
I'm asking for DSCP.
DSCP, yes, any PC will join. They have to first generate discover message that will be broadcast. Switch will flood that broadcast message to all other devices, and then server will generate offer message. Again, offer message is going to broadcast by switch. It will forward to all devices. So that's why I am telling you your broadcast domain should be small, and then PC will generate request message, and then server will generate acknowledgement message. Few messages are unicast in Cisco operating system, and in Windows operating system few messages are unicast, few messages are broadcast. But in Cisco IS, all messages are going to broadcast. All DSCP message is going to broadcast in
So
Cisco
in this
IS.
network scenario which you have shared over here, that switch will contain any information of DNS, DSCP, or HTTP
No.
server?
We can
That will
configure
not.
it, but no.
Okay.
We can enable DHCP service on this switch also. But here my DHCP server is this one. So these devices which are not going to maintain any information of DNS or DHCP. Switch don't know which type of traffic PCs are generating. Switch only know the packet at layer 2. That what is the source and what is the destination. That's it. If destination is broadcast, let me forward one copy from my all interface except the receiving interface. If message is unicast, then let me check the MAC address table, and according to that it will take forwarding decision. Any other dot?
Yeah, actually I'm asking because that switch 4 having 3 servers connected, right? DSCP, DNS, and HTTP. So if this
Right.
switch has having the information like okay, this is the DSCP request, so it will directly forward the request to DSCP server, not the DNS and HTTP server. So
No.
unnecessary traffic
Switch
will not
don't
generate.
know. Switch
Okay,
don't know na who is DHCP server. Switch know only the MAC address of this machine. MAC address of this machine is this one. So whenever in the destination MAC address will be the MAC address of DHCP server, I will forward that traffic from fast Ethernet to /0. That's it.
Okay.
Okay.
Yeah.
Anything else, guys? Any other question?